don't think that the attitude is healthy, regardless of how much you couch it in, but at all. Anybody's own efforts, and we all know that. Factors contribute, yes. But this kind of rhetoric is popular precisely because
الكواليتي بتاعت البتاع ده شغال ولا لأ؟ لأ استنى، البتاع ده شغال ولا لأ؟ اوكي. آه معناه ان الابلود سبيد هتبقى كويسة. ماشي. ها done it. What are we gonna be doing today? But I kind of forgot I did, so I'm kind of like revising what the hell I'm doing, and yeah, let's go here and static compile time form they comes to the data being laid out in memory. I'm going to be able to see right. Wait, that's just like this. Okay, unique is to indicate that a pointer is not used in any other. Huh. So if we use this, if type of answer, type of distinct Ball. Else. Uh-huh. Okay. Okay. Should keywords be context dependent? Very heavily leaning towards no. Yeah. Yeah. I mean, it's better to be this way. I don't want any confusion when people are using the language. I don't want it to always be kind of context switching. I need to have like a normal level of hey, hello, Assalamu alaikum, Muhammad. What's up? Yeah, I need people to have like a normal, simple way to deal with the language. So this probably is gonna be right. We're not gonna make the keyword be context dependent because yeah, just because I want the yeah, I want it to just be working fine for everybody. What other operators should be supported? Pipes and pipe symbol using this. I think I'm okay. Well, let's have a look here. Note. I need to find a language routing feature have different style slash baking. E.g. Jai meta programming meta program All right. So what else do we need? Aola. Let's see. What's the 50? Let's see this. Yep. So I can see it. Should I have features from Rust like safe and unsafe? I really wanna have a way to include safety heavy checks, but not as Rust does. It is very cumbersome and annoying to open or actually know what the F you want to do and don't want to keep compiler when they are exploring new ideas. There's a lot of thinking in this. How should I add functional type features that are good for developing actual code? Yeah, we're gonna need to think of that using the auto keyword. I think I'm just gonna have this default. Nope. Using as for finding and then set casting. Modules parameter. Question. Should these be used as function modifier? Probably not. We don't want city. All right. So Does the focus editor have any new updates? Let's see. Focus editor. Huh? 3.8? The fuck? Nope. It's the same thing. Okay. Huh. Assembly. What? Okay, mem copy. Oh, okay. So, yeah, I remember. I was talking to someone on Discord, and we were kind of discussing the idea of what things can you do in functions that you, or in assembly that you can't do in functions, or what exactly does the compiler. Yeah, I remember like talking to someone about this, and yeah. This is weird. Wait, let me check the. What's the case in here? Oh, like the number of viewers is kind of fluctuating. And nobody still don't have like. This is weird. Wait, let me check the. What's the case in here? It should be working fine here. Like the number of viewers is kind of fluctuating. And nobody still don't have like. Yeah, YouTube is working fine. We can just like turn that down. Okay, yeah, we don't have any viewer on Twitch, either on Kick. But yeah, I just want to do it. Hell with any viewers. I just want to do some shit here. Okay, yeah. So here's another weird idea that I got. Yeah. So here's another weird idea that I got. Yeah. So here. Shut up. What the hell did that work? Yeah. Anyhow. Wait. So. Here's the thing. Auto-like function overloading. And why? So you do like proc. For example, on delete, you could define a procedure that is called, hey, let's call it delete, or push. You know what? Like, yeah, that's called push. A lot of people know. That is a proc, and you just like do that. And when you do that, you could say, hey, push element push array of elements push dynamic array of elements. Yeah, for example. And you'd have like these being defined elsewhere like that. Yep. So these will be something like that, proc, and each of them we're gonna have like whatever the hell, something like this, and whatever. Oh, it's gonna be proc. Yep. Okay, yep. Which is weird. I don't really like it because, like, what's the point of that? You know, like, if the point is just like, hey, I want to have different implementations that differ by the function signature here. Well, yeah, I still think that it doesn't make sense anyway to keep doing like naming them different names, because what's the point of that? But well, okay, one good thing is when the reason why it not CMake, fuck CMake, it makes it easier to get the right function call when you know exactly what you want to do, and any mistakes in the function signature will make it or by accident. That's one reason why you may want to do like function overloading like this. I think the C++ like is much better. Syntax for wait. Hmm. Okay, so yep, these two are, well, they're basically the same thing. So hmm. does it mean the abstract language? Well, first of all, sorry for not seeing your question when you asked it, but abstract is the name of the language. But the whole idea of it is that people kind of think that the syntax of the language, like the way you declare a function, the way you describe variables, the way you describe relationship, the way you describe assignments, is kind of deterministic of what your language can do, but it doesn't, and it shouldn't. Code is just like an input. Like your compiler's internal implementation defines what these like characters really mean. So my idea is, well, if you imagine looking at something like mathematics, hey, a plus b, like, hey, let's have it in a comment here. So a plus b here, c equals a plus p. Mathematically, that doesn't mean any specific, not mathematically, like this way of writing a, like c equals a plus b, doesn't really define what exactly is happening. Okay, so if we're talking about programming, for example, you could say that, oh, c is a variable that is gonna be assigned the value of a plus the value of b. But also you can do operator overloading. So what does it mean to say a plus b? Well, if they're numbers, then a, if it's 5, plus b, for example 6, added to each other is going to be like 11. Okay? But that's not only the case. If, for example, a and b are strings, then we do concatenation. So h plus I is going to give you hi, the word, concatenated to each other. And in mathematics, it's the same. Like a and b could be matrices, could be tensors, could be scalars, could be whatever. Could be vectors, however you want to define it. The syntax, or the way you write it, doesn't define how it's going to be implemented. Okay, so my idea is that I want to, well, first of all, not only do that, but first of all, I want to design the syntax that allow me to make the language such that I could use the same syntax to A, make a programming language, a low-level systems programming language, that have an interpreter that lets it act as if it was an interpreted language, aka like half compiled or like interpreted language. Because just like if you run the compiler at compile time, it is just like when you're doing the code, if you output the result, this is just an interpreter. Okay, so an interpreter is basically a just-in-time compiler. That's one thing. And also, because in the hardware descriptive languages space, or the hardware design space, we use languages such as HDLL languages, which is hardware descriptive languages, that does not tell a certain computer like what to do or what instructions to run, but like describes the actual architecture and components of the system and how they're connected to each other. Also in behavior modeling, you're kind of like describing the mathematical equations that govern the behavior of the blocks in behavioral modeling. So you're kind of doing it in a different like conceptual mode, where one, you're telling a general purpose computer like how to do things, and the other thing is like you're telling atoms how to get together to create a chip or like any like sort of hardware. So I'm trying to design like the syntax, the one for all syntax that's going to be used in each and every single one of these scenarios. Okay, so yeah, that's the gist of it. So you could think of it as like abstract. The language that I'm doing is the sort of abstract design that separates the syntax as an input to the implementation of the compiler and the output of the compiler and whatever that's going to be. Because even like in hardware, we don't call it compilation. Well, in some sense we call it compilation, but that's like compiling the syntax. But at the end of the stage, you're doing synthesis. You're outputting the hardware structure that should be designed and fabricated. So yeah, that's the gist of it, basically. So yeah, that's it. The code feature. Variable initialization syntax for structs, arrays, and functions. EDC for basic types, for integers and floats. Okay, yep. Well, yeah. Okay, integer, float, boolean, hex, octal, and decimal. Yeah, that's it. So, well, this one and this one are kind of the same, but like this is just like a way to decide it. This is going to be useful for hardware descriptive languages. String, just going to be like that. So this is going to be a multi-line string, basically. Yeah, this is my genius word for using latex-like syntax for symbols. Like, hey, times is going to be this. And you're just going to look, hey, how does latex like replace this times operator? And it's going to show. You're gonna have a smart editor for that. Okay. And yep, arrays, we're gonna do it like that. Hey, array floats, whatever the hell is that, whatever the hell that is. Oh, that's the, oh fuck yeah, that's the structuring syntax for range based for ranges. So you have a range here from 1 to 4. And this is like inclusive here because we don't want to like do weird shit, basically. And you're destructuring this range to put it here. And then structs are going to be this way. I'm going to design this way. Yep, basically, that's it. Well, what? Oh yeah, that's the the definition. And there's other ways to think about like assigning structs. So you either do it this way, we're defining the struct here. Hey, I want to have this like that, or well, doing this is also okay. Doing this, yeah, well, I don't know. Probably this is gonna be a smart idea to use because it differentiates this from this, and it doesn't put an overhead on the compiler. But yeah, what the fuck? It doesn't matter really. Is this okay? Why? Yes, because it has this, which could be considered like a statement. Yeah. And then you have this, which is like, wait, isn't this the same as this? What the hell? Cool idea, but is it practical? What is V? Wait, V. Oh, destructuring structs. Damn. Yeah, I think that's what was meant by that. Structs. Functions is gonna be this. What now? وفيك بارك. شكرا على الدعوة الجميلة. Should function braces not be necessary. I'd much rather them be necessary than be stupid. Why would anybody want that? Symmetry. Static arrays. Huh. Okay, slide. Okay. Yeah, I really should. By specified enums, these enums are enums to any other type integers. Setting a value in this case to the identifier is a must. Value specified in what again? Enum. Oh, yep. So if you have an enum that you wanted to have a specific value, like, hey, I want my enum to be a string. Well, Yep. Okay. Non-exhaustive enums. So these are enums. It means that the language won't prevent the user from using values from the in the enum calling. Which the user can to order the one specified the entire range of the values from the enum defined in the right is a must. Yep. Okay, should we make the underlying type and an enum union? Probably yes. Yeah. Could I make flag be just a single? Mm. You know. Okay. Hmm. Huh. Okay. Okay. Boom. So from 0 to 9. From 7 to 0. Yeah, let's see. طيب هنعمل ايه هنا بقى؟ Yeah, so these were all so this looks like more like English. Okay, so using iteration macro or use I don't know. For iron map using the iteration macro. I don't think so. I don't know which one is better. Hi, what is programming language design? Well, basically designing a programming language, like a new programming language. Right now I'm kind of perfecting the syntax for the new language that I want to do. Like I'm not really sure what's the question exactly. Could you be more descriptive on what you want to know? Okay, so I mean, I didn't really explain that good. So okay, so the idea that I'm doing a programming language, the main concept behind it is that syntax should not be influencing the semantics of the language. And since I'm working in both hardware and software engineering, I'm exposed to using similar words from English or mathematics or whatever, like similar to programming language, to describe different things that require different understanding and different concepts when dealing with. So in normal computer programming, you're using the keywords of or the syntax of the language to tell the CPU or GPU what instructions to run on what parts of memory to take some data, do some processing, and generate some output, basically, or move shit around. And that's one thing. The other thing is that in hardware languages, we do what's called like hardware descriptive design, which using the language would look like a programming language, but we use it in a very different conceptual mode. You're not like when you say A plus B, you're not really describing software instructions that are going on, but you're more describing what hardware is going to be generated and manufactured later. So when you say that A equals B, mean you've just like connected wires from A to B. Like these are two ports that are now connected by wires, basically. And that's it. Okay, wait, you're something. Is it a general purpose language or oriented towards UI and graphics? No, it's way much more than even a general purpose programming language, because it's not just like a programming language. It's a language. That's why I call it abstract, because it's not a specific sort of language. It's just like syntax that runs on many different implementations that output different things for different use cases. So for example, you're gonna use this syntax to make a systems programming language like C, C++, that can also be interpreted, which is there's no difference anyway. An interpreter is just a just-in-time compiler. Or you could use the same syntax to generate hardware like logic gates and stuff that creates chips, or simulate or behaviorally model like analog circuits. So it's a syntax that could be used for many different applications. And I'm trying to find like the best way to design the syntax for like to encompass everything, because I don't want to just like, hey, I'm gonna make the best syntax for software that's gonna be a fuck you situation for hardware. No, I'm trying to do something that will work for both, and amazingly it's turning out to be the best for everyone. Like when I'm trying to design the syntax that works for software and hardware, I turn up like looking at ideas from both sides, and when I combine them in the right way after like deeply thinking about them, I end up generating syntax that is better for software and hardware than every language that I've encountered before. Granted, this syntax is heavily influenced by other languages that I've used before, like Odin, Jai, C, C++, Zig, Verilog, Verilog A, and all of these languages. Right. So, yep. Well, yeah, to hell with that. Yep, so... Oh, yeah, fuck that. Bum 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 ba da da ba da 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 da. Okay, my struct has keys. There is going to be a dynamic array of type. Okay, so K and V type K and value. Values are going to be well, I don't know, whatever implementation of that, well, whatever of type V. Okay, so when you say macro that does some shit and returns some shit and does some shit also. So okay, and returns whatever. So you're gonna use a here. Let's can we copy this syntax? Map. Yep. For key and value. And hash map, and we're gonna use this. No. We're gonna be using this. Like that. Well. So in this example, the iteration macro is the engine, map is the method to use for the iteration and value data. So the iteration macro is the engine, map is the method to use for iteration, and value is the data. Oh no, you got it quite like pretty much upside down here. So here's what it means. So my hash map is just a struct. So any data structure is just gonna be, hey, a hash map is just gonna have like, hey, a keys, which is gonna be like, for example, yeah, I didn't really do it right here. So hash map is gonna be like, hey, my hash map of what? My hash map of, yeah, say what? Error code, and let's say message. Okay, let's say that we have like some enums here, whatever the fuck it is. Error code is some sort of an enum. Okay, that's whatever, and message is just like an overloading of string. Okay, so my hash map is gonna be like this struct that contains like keys of type key, which is gonna be error code here. That's a short enum, and values that are like arrays of strings, basically. Like you can think of it as like, hey, it's a dynamic array of strings. Okay. And then like here, this is a variable definition. So map, just a normal map or a dictionary, is a hash map which its key is of type error code and its value is of type message, which is just a string. Okay. So what we're doing here, we're saying, hey, I want to iterate over the value and key. So these are arbitrary names for the return values of the iterator. Okay, so this could be like, hey, this could be named like val and key. Okay, it doesn't matter what are these named. You're sort of like, hey, like, you know what you do in Python for I in range, like I here isn't really anything. You can like for index, right? You can do it like this way. So here's the same thing. You're just like, hey, I'm gonna be expecting the values that I'm looking at and the keys that I'm looking at. Okay. And this is just the syntax that, hey, these values are gonna come from the map that I'm using. And then here we're gonna say, hey, since like this type isn't really like a built-in type, you gotta define like how I'm gonna iterate over it. Okay, so I'm using here the iterate hash map, my hash map, and what this is gonna do, like what this macro is gonna do is that, hey, it's gonna tell me, hey, you're gonna use this key here, you're gonna use whatever fucking hashing function to find the what, you know what, this is also like yeah, because probably this is not gonna be an array, this is gonna be like a pointer to some memory of v's or whatever. Yeah, whatever, it doesn't matter what's the type here, fuck that. Okay, it's gonna be whatever it is to a type of v. Okay, and you're gonna use the hash map here. You're gonna like iterate over this array. You're gonna get the first key. You're gonna go, hey, I want to find the place of the value of this key. You're gonna use the hash map here to find the place in the memory that you're managing by this hash map. And you're gonna return the value and the key here because the user asked for the value. Like you can emit the key and only get the value, but you can also ask for the key. So this defines how you're gonna iterate. This is the thing you're iterating over. This is the values that you're expecting. Okay, and this is like the body of the for loop. I hope this was informative enough. Okay, so I think we solved this like last time. Solving the bit field definition problem was all the array range versus whatever the bloody bullshit is that. Okay, so bit field slicing. Yes, we're gonna do the exact same thing. Okay. Bit field slicing. So this is gonna be like this. Okay. For array destructuring. Bit field destructuring. Virtual address. Yep. Okay, using this for variadic arguments. Okay, so this is solved then, right? Range style bit fields. Yep, these are gonna be right like that. Because we decided on this to be used for the for loops. So we really should just like be working with this relic style. Arrays of bits. Yeah, no. So there's gonna be a RAM, there's gonna be an array of this, and we're gonna be having this. Conditions. These are gonna be. No, what's con? Oh, concatenate, right? Yeah, concatenate. All right. Yep. Array bit field slicing. So this is working fine. This is fine. This is fine. Finalized. So all of these should be finalized, right? Yeah. Should we have matrix types in the length? Wait. Yeah, I think we had this question up there repeated somewhere. What now? Should I have features model? Should I have fine? Yeah, we can take this one here. Yep. Huh. Wait, why? What happens if a slice falls out of range? You had the slice like 1, 2, 4. Well, first of all, the 1 to 4 range is inclusive. That's one thing. The second thing is it's checked. Like by default, array operations and array indexing or slicing is bound checked. So if you say, I want to slice from an array, it's going to be checking, hey, what's the size of the array? If it's outside of the bounds of the array, it's going to give you an error. So like at runtime, for example, if you try to, hey, I have an array of 5 elements and I want to slice from element 1 to element 50, you're going to get an error. Hey, like If it's at compile time and it's a compile time known array, you're gonna get a compile time error. Hey, you're trying to slice an out of bound index from this array. If it's at runtime, it's gonna give you a runtime error. So that's the gist of it, basically. Yeah, I really like what you're saying, because these are actually really good questions, man. So wait, what's this language? It's a language that I'm doing myself. So it's a new language that I'm creating. Okay, so what else are we doing? So we did solve that. Okay. Implicit polymorphic functions. This should yeah, this should really go way above all of that, because I think this, like most of these, like the things on the bottom are really things that we kind of finalized, right? For loops, I mean, I don't know why for loops are not just like finished. Variable transition syntax, yeah, let's have this one kind of here, because I don't really know still what I want to do with it. Because like this may be like very useful if you want to just like, hey, I just want to pass a like a lambda function ish style, a lambda style function in the middle of like, hey, for a transform function that's gonna iterate through a range and just like gonna apply a lambda function to it. I don't know. This is still under construction yet. And yeah, I think I'm not gonna be using this syntax anymore. So it's probably gonna be using this syntax. Okay. Even though I didn't want to use this originally, I still think it's gonna be the best. You know what? Let's leave this, because I wanna like revisit where I did like, I don't exactly remember where I finished my thought on using what syntax for applying this. Okay. Yes, sir. Variable initialization. Yeah, that's all that's finished. Yeah. Okay, so these are the hygienic macros. So yeah, here for expansion. This is gonna be like the for expansion that's gonna be used for the for iteration. Hey, you're gonna take the range, you're gonna take the index, you're gonna take the pointer. Are you gonna do you want it to use it by pointer or by value, reverse or not? Oh, I didn't really, shit, huh? That's one thing that I didn't really decide. Like, do we wanna have syntax for reverse iteration or not? Yeah, that's let's jump here for the for loop. Yes. Note, what is the syntax for reverse iteration? And find out what other languages. Okay, where can I find / use this language? So this is the syntax tree stage. Well, yes and no, because I did have some where. Oh yeah, I didn't open the terminal. So I did start. Dude, what's wrong with? Ah, come on! Are you fucking kidding me? Okay, so yep, let's do that. City projects abstract. Easy abstract. Is it this one? Yeah. Main.cpp. Yep. So I did start the implementation of the compiler, but it is nowhere near. Wait, why is this not? Dude, what the hell? Okay, yep. So it is really nowhere near getting what's it called? The final implementation yet, but like as you can see, here we have the parser. That's a lot of shit that we don't use yet. Yeah, so here you have the this is the Lexer. So I did do some quite some. Wait, what's that? Oh no. Yeah, I'm not gonna save anything. Okay, so yep. I did start the implementation, but it is nowhere near outputting the use case yet. What's the S for the index? Oh, I missed that one. Oh, you mean in the wait. Yep, yeah, I think you mean here, right? Well, so it is not really. So these are like filler values here, because like, well, so S64 is just like signed integer, like in Rust you type it this way. Okay, so here I use this way. Okay, this really should be Boolean, right? Because okay, so there's gonna be like a language specific way to define macros for for loop expansion, which are the macros that are gonna define the iteration. Why? Because you wanna, hey, what's the range that you're iterating over? Okay, so you're gonna need the range and the range you're iterating over is going to be of the same range type as the range you're going to be taking. Okay, so in the case of the iteration that I showed before, this is going to be of type my hash map. Okay, then do you want to get the index? Like if you added if you did this, like, hey, for like by default, the default use case is like hey, value in, like, for example, hey, I have an array that is like 1 2 3 4 5 or something, and you're gonna do, hey, for value, what like, somehow I'm forgetting like how to spell words right now. Okay, like for value in array. Okay, by default, array expansion is going to be supported by the language. Okay, so you're not going to need to define the iterator. But what you can do is you can say, well, here we go. Like if you did this, then you have a variable called value that gets like assigned like each value of the array throughout each iteration of the for loop. But then you can say, hey, I want the I or IDX or index. Okay. Here, this is gonna be true. Like in the previous case, like without this is gonna be false. Do you want the index? This is gonna be false. So it's gonna be like a flag to tell the logic inside of here, like, do you really want to give back the index or not? And yeah, based on that, you're gonna decide like which kind of logic that you're gonna be doing here. Also here, you're gonna be deciding, hey, are you expecting to take the values by reference or by copy or by reference? So for example, if you did this, then let's imagine that this was not like a very what's it called, a very dumb array of integers. Like let's imagine that each element here is like a string, like whatever the hell is that, like, okay, well, like imagine something like this. So strings are big. Copying each string every time is going to be like very bad for the performance that you have. So you can say, hey, I just want to copy it by pointer, and if I needed to change it, I'm just gonna like access the original data. Or like, hey, I want to be able to change the strings like inside this array. So you might want to, hey, for value inside of the array, don't bother with the syntax here, but I'm basically saying, hey, dereference this value, because this is a pointer. Okay, so dereference this pointer and assign it to the value of modified whatever. Okay, so that's the use case for, do you want the pointer here? And if you want it reversed, you can have a logic here to be reversed or whatever. So these are like just like basic ideas of what I would want to use as inputs to the macro for the for expansion. Okay, so yeah, that's it. Using a keyword for making the statement pass through. Okay, yep. These are still, those can insert code at the beginning. Like for example, if you used a for expansion, okay, what happens really, and this is like, okay, so here you know what, reserved place for the keyword to basically, so imagine this is the body of the for loop. What happens here is that like it's gonna like embed a value of code. Hey, you have the value that as if you said scope. So if you call this, it's gonna insert some code. Clear on which one of these to use. Yeah, this is not. So since these two are still not decided upon, then we could like throw all of them at the beginning here, right? Yep, that's the code feature. Yes, and we can have these here. We want to be able to decide all of this. Yep, the bit slicing, everything, data passing. Yep. Okay, so next part is what is data passing, declaration and passing. Oh, data. Wait, what? What do I mean by? Oh, so path is the input, output, and in out, and the passing. Yeah, I forgot what I was defining them at. Yeah, so for performance reasons, okay. So here you're gonna have a tree that is a path by reference and in out to a node and a sorting function. Okay. It takes something, return something, and it's gonna result in a huh? What the hell is that? Sorted tree that is of type oh no, this is not gonna do any return anything. Implementation. Yep. So yeah, should all types be inputs? In terms of how defining address, this could be fine, but it's going to be redundant. Yes, remove index container as an in out container and the index. Yep. Yeah, I think I decided that this defines if it's passing by. Well, if it's an in out, then it for sure needs to be a reference, a passing by pointer. But I think I decided that this part is going to be the part that says that you can modify it. Right. That you can read and write to it. Well. And implicitly define the address part. Yep, that's gonna make sure that it's passed by a pointer. because in order to be an in-out container, you need to have by address and these. Yeah, so all of this is kind of finished. Okay, so what else don't we have here that we had in the yep, that we had in here? Yes, so this was taken straight from this file. Yep. Automatically invoke structure member defining function. Yeah, so yeah, I wanted just to define this here. Yeah, I need to remember this. So this is gonna be the entity, and it's gonna return a reference to the V table. Okay, so it's gonna be a type under reference to the V table, pointer to the array. The door state, the door. Yeah. Gonna be an entity, and V table is gonna be have like, okay, two functions. One is init, one is print. Okay, so a pointer to the V table. Oh, yep. So whatever is inside the V table is going to be defined directly in here as part of the entity, and it's going to show in here. So it's as if we are using the pointer V tables. Ow. No, wait. Okay. Yeah, I think we're gonna need to make this a bit wider here. Okay. Door V table, human V table. V tables is an array of pointers to V table that is auto pointer to V table, auto pointer to auto V table, and then door is gonna log door entity, here entity door dot print. Okay, wait, but why is that here? Entity type and a VU that returns of the V table. So I think this needs a little bit of work. Entity v table. It's gonna be v table. Nope. V table is not gonna do anything. And these are just gonna have this. Ba-da-da-ba-ba-ba-ba. So inline latex. What? Should I use this? Baby. Meta programming. The compile and multi-parameters, function parameters. Have to be done. Okay, find a way. Try. This is very easy to do. The likes for the reduction. You need to make sure that right. Then the truth is going to reduction, the declaration, or the tender. No, bad idea, bad idea. What makes this? Instead of being done at truth function could be ran at compile time. This might. Edit. Do you run the for run the function at compile time or like templates? Okay. And it also lags the authentication of the compiler action. Yeah, this is a problem. Also, when it comes to struct, was that the parameters? Did you use type? It's like template parameter. Did you use parameter function structs? Galaxy is a casual. Quaternion. Top. Yeah, go fuck yourself. Yeah, I think I'm gonna stop here because I need to, yeah, go for some refreshment before sahur. I need to make some. Yeah, I need to make some food for my sahur. Yeah. Okay. So yeah, that's it. Have a good time, guys.